Hey guys, welcome to Pre-Calc Lesson 12.9. Because you didn't get enough last time, we have more continuity. All right, so let's dive right in here to our first example. I want to make f of x continuous. If f of x equals square root x plus 2 minus 2 all over x minus 2. So again, if it asks you to make something continuous, you know it has discontinuity. It's going to have discontinuity where that denominator is equal to 0. Well, I don't need to write out an equation to determine that it's got discontinuity when x is 2. So what do we need to do then? Well, if you know it has discontinuity there, we next need to take the limit of that function at that value. So as x approaches 2. Well, there's a problem with that because if you try direct substitution, guess what? I'm going to get something that does not exist. Well, this is really good practice for when we first started evaluating limits earlier on in the unit, and we had a square root. How do I deal with this square root? And if you remember, what we need to do is we need to multiply the numerator and denominator by the conjugate. So I'm going to multiply by square root x plus 2 plus 2 over square root x plus 2 plus 2. Because we said that the problem area is this. I need this to go away. Well, the only way this is going to go away is if we can cancel it with an x minus 2 in the numerator. So let's see what happens when we multiply this stuff out. Now my denominator, I'm really not going to multiply out. I'm just going to write x minus 2 times this conjugate of square root x plus 2 plus 2. Now, what's going to happen in the numerator is when you multiply these two, because they're conjugates, you really just need to multiply the first terms and then the last terms. So what we're going to get here is square root x plus 2 times square root x plus 2 is simply x plus 2. Then when I multiply negative 2 times a positive 2, well, that gives me negative 4. So now I can clean this up right here. X plus 2 minus 4 is simply x minus 2. And now in that numerator, I see that this and that are going to cancel. So what I'm left with, I'll have to write small here, but 1 over square root x plus 2 plus 2. So now I can take that limit. I'm going to take the limit as x approaches 2 of 1 over square root x plus 2 plus 2. Plug in a 2, 1 over square root 2 plus 2 plus 2. Do a little mental math here. That's going to be square root of 4. That's going to be a 2. 2 plus 2, that's going to be a 4. So this limit right here is simply 1/4. All right, so I've done a lot of work. I haven't answered the question yet, but I've done a lot of work. So what do we know? We know that this function has discontinuity at 2. The limit exists at 2. That tells me it's point discontinuity. So here's what I've established. I've got this situation graphically, and this coordinate right here is 2, 1/4. So what I need to do now to make this function continuous is create a piecewise function that has this everywhere except 2. And then at 2, I need to fill that hole, and the y value's got to be 1/4. Okay, so let's write all this out. My piecewise function is going to be the original. So square root x plus 2 minus 2 all over x minus 2 everywhere except 2. Okay, so now what we're going to do is we're going to create a point that fills that hole. So that's going to be 1/4 when x equals 2. All of that work to come up with this piecewise function. Okay, that's one of the more challenging ones you'll probably see. Let's move on. Let's review finding the value of a that makes f of x continuous. So here we have a piecewise function. That's a cubic from negative infinity to 2 inclusive. And I've got this linear function here from infinity to 2. So if I just make a quick sketch, I don't know if this is going to be close or not, but I've got some cubic, stops there. And then I've got a linear function like that. And what we need to do is we need to find the value of a that's going to allow this piece here to line up so that now it's continuous. Well, basically, again, here's what we're doing. Left-hand limit, right-hand limit have to be equal. So I'm going to take the left-hand limit and right-hand limit of f of x. And again, notation is very important. So the limit of f of x as x approaches, remember, this is the only place they could have discontinuity, 2 from the left. Then I'm going to take the limit of f of x as x approaches 2 from the right, and then those two limits have to be equal. So the limit of f of x as x approaches 2 from the left is negative infinity to 2. I'm going to use this, x cubed minus 3. 2 cubed minus 3, that's 8 minus 3, that's 5. The limit of f of x as x approaches 2 from the right is going from infinity to 2. So I'm using this, 8x plus 5. X is 2, so that's going to be a times 2 plus 5. And now I just need to set those equal. So 2a plus 5 equals 5. 2a equals 0. A equals 0. That's the value of a. That will take this piece right here and line it up with the cubic so that it's now continuous. All right, and our last example. This is similar to that first one, a little bit easier to find the limit in this case because we have a quadratic and not that radical in the numerator. So again, I want to make this continuous. I have to establish where it has discontinuity by setting that equal to 0. Okay, so I know it has discontinuity at x equals 3. So then we need to take the limit of f of x as x approaches 3. Well, let's clean up this top. Let's factor that. It looks like it's going to be x minus 5, x minus 3, and then x minus 3 cancel. So when I take this limit, I'm really taking the limit of x minus 5 as x approaches 3. 3 minus 5, negative 2. So again, I want to make sure you guys understand visually what's going on. We have discontinuity at x equals 3, but the limit exists. So what that tells me is I have point discontinuity. So visually, what we want to do is if we have a hole in the function, I want to create a piecewise function that then fills that. All right, so here's going to be the solution. F of x equals the original function, not the simplified version, but x squared minus 8x plus 15 over x minus 3, everywhere except where it has discontinuity. So everywhere except 3. And then when x equals 3, what we have to do is we have to fill this hole again right here. So that's going to be negative 2. And that is a function that is now continuous. Okay, that's it for this lesson. Again, it was just a little review of the last one because it is sort of a challenging concept. Please do the associate homework. Keep plugging away on those work sessions and reviews. And again, just reach out to Mr. Ward or myself if you have any questions whatsoever. Thanks, guys.